Alright, good morning everyone and salam sejahtera. Today we continue our lecture on chapter 7 part 2, allowable stress. Alright. Okay, before we go into further study, we do some revision. Alright. So the revision, right, previously we have learned regarding stress. Alright. Stress we divided into two, which is normal stress. Alright, and then the shear stress. Alright. Okay. So the formula is same, but the symbol is different. Here you have sigma, here you have tau, and you have force over area. Force over area. But symbol for this one is a bit different. You have P over area, and you have V for shear load over area, or V over 2A. Alright. This one for single shear, and this one is for double shear. Alright. Okay. So basically for this one we use for pin connection. Alright, for shear. And this one you have used for rod ataupun or bar. Alright. So you have force over area. Okay. Let's say you have this bar. Alright. You have load in this way, P. So this is the area lah. Sigma is P over A. Or you have pin. Alright, you have pin. So you have load in this way. Alright. So this is the area. Tau is V over A or V over 2A. Alright, this is V. Alright. The unit is sigma is equals to Pascal or Newton over mm squared. Okay, you can use this one, or you can use not this one. Pascal is Newton over meter squared. If you use megapascal, you simply can use Newton over mm squared. Alright. Okay, that's our solution. Now we go into allowable stress. So what is allowable stress? Maximum stress allowed to be applied on a structure for safety reason. Right? Many unknown factors that influence the actual stress in a member. A factor of safety is needed to obtain allowable load. The factor of safety, or Fs, is ratio of the failure load divided by allowable load. For example, F fail over F allowable, sigma fail over sigma allowable, and tau fail over tau allowable. Alright. For example, you have a lift machine. Okay, you have lift, alright, and you have people inside here. Alright, you have people inside here. So basically the allowable yang dibenarkan masuk dalam lift adalah, let's say you have 10 people. Alright, this is 10 people. Alright, and fail is 20 people. If you put more than 20 people, it will fail. But the allowable one is 10 people. Alright, so factor of safety is 20 divided by 10, you have 2.0. So that's mean by allowable. Same things with the stress. Here I use the example of people, but for the stress it's the same thing. Alright, and then for the structure, alright, the same thing. So allowable is much more lower than the failure. Alright, if you have this bar, alright, this bar, you have load P. The maximum may be 20 megapascal, fail, but allowable may be around 50 megapascal. Alright, this sigma fail and sigma allowable. Alright, the factor of safety is 200 divided by 50, you have 4.0. Alright, so load yang dibenarkan. Alright, so example, you have given allowable stress for road BC. So this is road BC, alright, is 115. So sigma BC is 115, and allowable stress for pin A and B is 90. Why I use tau? Because pin is shear, 90. Tau B is 90 megapascal. Alright. Okay. So find the diameter of pin A and pin B and diameter of road BC. Alright. So let's find out. So A here is double shear. If you look at the diagram, it's double shear. So this one is single shear. I already explained in previous lecture how to determine double shear and single shear. Alright. So let's do our own. So we have here AX because this is pin, right? And you have 6 kilonewton. And you have FBC, only one direction because this is two force members. Same with cable in your test. If you have cable, you have only one direction. Alright. So summation of moment at A is equals to 0. So this one is 2, this one is 1. So minus 6 times 2. So 3, 4 and 5. Plus FBC times 3 over 5 times 3 distance is equals to 0. So you get FBC is equals to 12 times 5 divided by 9. So you get 6.67 kilo Newton. Alright. And then you need to summation of Fx is equals to 0. So you have Ax plus FBC 6.67 times 4 over 5 is equals to 0. So you got Ax is equals to 5.3. Alright, you have 5.3. I got here 5.34. It's okay. 5.34 kilonewton minus. Alright, minus. So it's basically 5.34 kilonewton this way. Alright. And then you have summation of Fy is equals to 0. So you have Ay minus 6 plus FBC 3 over 5 equals to 0. So you got Ay is equals to 6.67 times 3 divided by 5. You got Ay is equals to 2 kilo Newton. So correct direction. Right. So Ax you have 5.32 or 5.34. Ay we have 2. So you need to find the resultant. So resultant is simply 2 squared plus 5.32 squared and you square root. You get this answer. Alright. And then you got the FBC is 6.67 kilonewton. This one. Right. So the question is to find the diameter of pin A and pin B. So we start with, so where's the location of pin A? So pin A is here. Alright. So this is A. So look at their force. Okay, we start with pin A. Pin A is, if you remember, pin A is double shear. Alright, and the force on pin A is 5, 6, 8. Alright, so it's 5, 6, 8. And then sigma, tau is V over 2A for pin A double shear. right? So force is 5.68 kilonewton over 2a pi ra squared, alright, is equals to 90 mega Pascal. Okay, so you can find the RA. Alright, so 90 times to the power of 6, right, Newton Pascal is equals to 5680 over 2 pi RA squared, right? So you can find RA is basically, you will get, take your calculator, so you have 90 E6 times 2 times shift pi, right, 5680, 90 E6 times 2 times shift pi, right, so 5680 answer, and then square root, you get 3.17 times 10 to the power of minus 3 meter, right, meter. Okay, and then the diameter is times 2 lah, right, times 2, you get 6.34 of 3 meter, alright, or 6.3 mm. Okay, so you get the answer here for the diameter of A. Same with B, alright, same with B, but for B, this is a single shear, right, single shear. So single shear, the formula is, this one is A lah. So for pin B, tau B is basically V over A only. So the force at B is basically here. Force at B is here. Basically same with FBC lah. Alright. So 6.67 kilonewton over pi RB squared is equals to, same, right, 90 mega Pascal. So you find the RB is basically 90 E6 times shift pi over 6.67 E3, right, and then you square root, sorry, 90 E6 times shift pi, right, and then 6670 over answer, and then you square root, then you square root, you dapat 4.85, 4.86 10 to the power of minus 3 meter. So diameter is just times 2, you'll get 9.7 of 3 meter, alright, or you get 9.7 mm. So untuk selamat, for the safest, you take the larger value lah. If you have diameter 6.3, you take 7 lah. So it's safe. You cannot take 6 mm, it's become smaller diameter, so it will fail. So take larger than 9.7, alright, you did 10 mm, alright, or you just take the answer 9.7 is also okay, alright. So for road BC, alright, road BC, So sigma is basically P over A. So you have 6.67 kilonewton taken from here, 6.67, alright, and then divided by A. A is pi r squared is equals to 115 megapascal. Why 115? Because the question is 115 for the road BC. Alright. So you use the similar procedure, you will get DBC is equals to 8.959 mm. Alright. For the safe estimation, you get the larger one, which is 9 mm. Alright. Okay. So what if the question, I repeat a little bit, what if the question asking you they give you the ultimate stress, the failure. Let's say I change this one, given the failure stress for road BC is 115 megapascal. Alright, if let's say I take this one, 200 megapascal. Okay, so you need to, so they must given you the factor of safety is, let's say, 2.0. Alright, so find the meter of road BC. Okay, so if given you failure stress for road BC is 200, and then the factor of safety is 2, so you need to divide first. Alright, so this one you need to divide first. 200 megapascal, you need to divide by 2. Okay, then you can proceed with the calculation. Alright, for example, if the failure stress of road BC is, let's say, 200 megapascal, find the diameter of road BC. Okay, so using the same procedure, P over A, in fact you need to divide it 200 divided by 2. Let's say this one is factor is 2.0, so divide by 2, you will have P over A 6.67 kilonewton divided by pi r squared. Okay, so this one left with 100 lah. 100 megapascal is equals to 6.67 kilonewton over pi r squared. So you get the R, which is 100 is 6 times shift pi over 6670, right, and then you square root. Okay, 100 is 6 times shift pi, right, and then you got 6670 divided by answer, right, and then square root, you got 4.63 meter. Alright, or diameter is times 2, right, you get 9.2 mm. So this is your answer. Alright, okay, also you can use this as an answer, okay, or this one. Okay, so this thing I think you need just look at yourself. Alright, nearest 5 mm, that means 0, 5, 10, 15, 20. Alright, okay, the control arm is subjected to loading. Determine the nearest 5 mm required diameter of steel pin at C here. If the allowable shear stress for the steel is 55, alright, note that the pin is subjected to double shear. So do the same procedure, draw FBD. Alright, Find what is the resultant force at C. Alright, so here 30.41. Alright, since it is double shear, you must divide by 2. Alright, so tau is V over 2A. Alright, so tau is 55 megapascal. So V is 30.41 divided by 2A pi r squared. So you find R and you find D. Alright, okay, same answer, same solution. Okay, you got 18.8. So you spin the meter of T 20 mm. If you answer this one, is also okay. If this one is also okay, both are okay. Alright, but it's asking for you for the nearest 5 mm. So nearest 5 mm is the 0, 5, 10, 15, 20. So you use 20 lah. Alright, so this one, a rigid bar AB supported by steel rod AC having diameter of 20 mm and aluminium block having cross sectional of 1800 mm squared. Alright, the 18 mm diameter pin at C and A are subjected to single shear. If the failure stress for steel and aluminium is this one, and the failure stress of pin is this one, determine the largest load P can be applied to the bar. Alright, so it's given like this one. Alright, diameter, and find the largest load P. Alright, so first thing you need to divide the failure to the safety factor. You get this one, 340, and divided the failure with the safety factor, you get this one. Alright, so use this value to calculate the value of P. Alright, okay, same thing. First you need to draw free body diagram like this one. You have P, you have FAC, you have FB here. Alright, so using the equation of equilibrium, you find the moment at B and moment at A. You got this equation, alright, in terms of P. Alright, and then we will now determine each value of P that create the allowable stress in rod block and pins. So for rod AC, okay, for rod AC, this one, rod AC, where is rod AC? This one, rod AC. Okay, rod AC is basically rod is normal stress. Sigma is P over A. Alright, so sigma is how much for rod AC? This one. Okay, 680 divided by 2. Why need to divide? So this one is 880. Okay, 70 is what? 70 is aluminium. So this one is 70, and then pin, right? Pin is 90. So pin is 900. So each one you need to divide by safety of factor before we proceed with the solution, right? So for rod 9680 divided by 2, so you get this one lah, 3340. So 340 megapascal is equals to P, the force, P over A pi r squared. Alright, okay, so you find P here. Alright, you find P, you get this one lah. Alright, 171 kilonewton. Alright, okay, so you get this one, and same with other. Alright, you get the P 171, 168, and 183. So the you take the small value. When P reach its smallest value 168, is develop the allowable stress and aluminium block. Hence P is 168. You get 3 answer. This one, this one, this one. But you need to take which one? You must take the smallest one, so that the pin will be safe and the road AC will be safe. If you took this one, 183, the block B will be fail. Okay, and then the road AC also will be fail because P, this one is larger than 171. Okay, alright. Okay, thank you. I think that's all for chapter 7 part 2.